Hey everybody, this is Larry. This is day 23rd day of May. Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Today we have 2597, the number of beautiful subsets. Okay, I mean, we've been doing subset problems lately, so it's probably going to be 2 to the end. But we'll talk about it again. I don't know how much in detail that I'm going to do it today, just because we've kind of talked about it like the entire last couple of days, so you can go check that out. You're given an array nums of positive integers and a positive integer k. Let me move my yeah, a subset of nums is beautiful if it does not contain two integers with an absolute difference equal to k. Return the number of non-empty beautiful subsets of array nums. A subset of nums is an array that is obtained by deleting. Okay, we know what a subset is. At least I do, hopefully, and that you will understand. And again, because we want to check, is equal to 20. So we probably can do some 2 to the 20 stuff. So okay, a subset of nums is beautiful if this does not contain two integers with an absolute difference equal to k. So okay, so then now we just have to check whether any given subset is has that amount. And there are a couple of ways you can do it. You can basically, the naive way is going to, or maybe not even naive, maybe that's a good enough way, is just do 2 to the n, right? Like for every 2 to the n, just do an O of n check. And that should be pretty straightforward, right? And then it's going to be O of n times 2 to the 20, but that's a little bit slow, at least on Leetcode probably, because, I mean, but this is a silly part on Leetcode's pen, because can't really do better than that. I mean, you can do a little bit better, but it's always going to be just optimizations, right? So we'll do it the naive way first, and then we'll see if optimization will help. Okay. Right? I mean, yeah, the beautiful part about a lot of these things is that, yeah, I mean, you know, we can play around with it and then check, figure it out. Yeah. Okay, so then now we can just go, I don't know. I don't even know what to call these things anymore. Just recurse, right? Maybe index, n is equal to length of nums, k is equal to 2, okay, 20, okay. And then maybe we can just do a counter thing, but it doesn't even matter, right? Like, you can do it a number of ways, but the way that I do it with a counter is just easier to do it. Maybe, I don't know, right? But the idea here is then we now have, well, I mean, okay, the base case is going to do this, and if, I mean, we get here, then we're probably good, so we can return, or we can return, and maybe we can, maybe return 1, right? Yeah. I mean, the reason why I'm pausing a little bit is because maybe you should check if count is equal to 0, or the length of count is equal to 0, because in that case, then you should return 0. But you can also just subtract 1 at the end, so so that we can get rid of the empty subset. But so either way is fine, right? So then now we just return recurse of index plus 1. I guess we shouldn't do it this way. Total is equal to recurse plus 1 counter, or maybe return is equal to, you know, do this. Right, so this is the skip, right? So skip and tick, and if you kind of, you know, see where I'm going, it's very similar to, you know, counter of num sub index, oops, equals 1, and then we subtract it as well. But of course, we can only tick if counter of num sub index minus k is equal to 0, and same thing but plus k is equal to 0, right? And then we return total. Then we just return recurse 0. Just a new counter is fine, right? And you can also delete stuff if you like, but I think that's the general idea. And again, oh yeah, I forgot to, I said that I would subtract out the empty set, but I would say in general, don't, like, you know, just if you're off by 1, make sure you know why it's off by 1. But here I actually did say it and I just kind of forgot about it at the end. But it's very easy to remember once you see it. Let's give it a submit. Hopefully it is fast enough. It may be, I don't know. Okay. I mean, it's faster than the last time I did it. How did I do it last time? But it's still like very sketch, because in the worst case, it's going to be all of, oh, I did it this way instead of, but same idea. Because in the worst case, it's still going to be n times 2 to the n, which for, you know, n is equal to 20, it's like 20 million, which is a little bit too slow. So it's a little bit sketch. So it's a little bit just like waiting on Leetcode with things, right? For example, you can write something like nums is equal to, this times 20, well, and k is equal to anything that's non-zero, and this probably will run out of time. Why is that? That is actually surprising. Huh. I guess the way that I did it is, I guess I amortized out the extra O of n here instead of doing this way. So I guess that made it a little bit fast enough. But note that it's still not fast. It still took a second to do the worst case twice. So you're still at the mercy of Leetcode's input and stuff like that. So I don't know. But yeah, this is going to be O of 2 to the n. I guess I did make an optimization by accident. Because usually I check it at the, I was initially going to check it at the end, but I was like, yeah, we can just do it this way. I don't know. This is why you take wins when you get them. But that's all I have for today. Let me know what you think. I'll do a bonus question after this. Let me know if I do want to go over the thing that I did yesterday with the sub-arrays, with the possible number of sub-arrays, but obviously today's problem is not quite that. And I think today's problem is pretty straightforward in the sense that we have been doing it the last couple of days. The only thing that is new is just this thing, which is the absolute value difference is equal to k, which is something that I hope people will get to, of course, even if it takes a little bit long. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, do good mental health. I'll see y'all later. Take care. Bye-bye.